Hello everyone, welcome to my channel. My name is Rohan Pawar, studying in Sri Venkateswar College of Engineering, Bangalore. My USN is 1BE23CA037. Semester 2nd, section is Devo. Course code is BESCK204A. Course title name is Introduction to Civil Engineering. Today's my topic is about calculating the centroid. What is centroid? In civil engineering, the centroid is a crucial concept used to determine the center of gravity or the geometrical center of the structure or a body. It is a fundamental concept in structural analysis, particularly in design and concern of building, bridges, and other structures. Definition of centroid. The centroid is a point where the weight or mass of all objects is evenly distributed and is the average position of all the points in the object. In this video, we will learn how to calculate the centroid of any given problem. Steps to calculate the centroid. Step 1. Identify the given reference axis. First, we need to identify what is the given reference axis. If the reference axis is not given, consider the bottom part of the figure. Like this is a figure, we need to consider the bottom part of the figure as x-axis, and the leftmost part of the figure as y-axis. Check the symmetry of the figure. Like symmetry means it should be divided evenly through diagonally and not diagonally, horizontally and vertically. If the figure is symmetry about its vertical axis, then the total then x bar is equal to total width of figure divided by 2. Similarly, the symmetrical about horizontal axis is y bar, that is total depth of the figure divided by 2. If a figure is symmetrical, then divide the consecutive sections into non-geometrical figures. Determine the centroid using following table. This is the table. So this is the table in which there are 6 columns, mainly components. In this we will note down the shapes given in the problem. Then we need to find the area of the respective shapes or components. Then centroid of the distance from the x-axis, which we will have a formula similar as y-axis noted as x. Then moment of area about x-axis, that is a into x, and the moment of area of y-axis is area into y centroid. So here are some important geometrical figures of centroid shapes, which are a rectangle, triangle, right angle, triangle, circle. The area of the given shapes are followed here, same as x bar, y bar, and the figures. Just refer these bars. This is the table of centroid of some important geometrical figures. Need to refer for the formulas. Next, determine the position of the centroid for lamina with a circular cutout. This is the given problem we need to solve in this video. In this given figure, there are 4 geometrical shapes, which are a right angle triangle with the height of 60 mm and the width of 120 mm, and a semicircle of radius 50 mm and a rectangle of 120 mm width and depth of 100 mm with a circle of radius 20 mm. Solution. Components which are rectangle, semicircle, triangle, circle. Then the area, then centroid distance from x-axis, that is y, centroid distance from y-axis, that is x mm, moment of inertia about x-axis, that is area into y, centroid, moment of area of about y-axis, that is area into x-axis. So first we'll solve about rectangle. Rectangle area is breadth into depth, 120 into 100, that is 12,000 mm, and the depth centroid is depth divided by 2, that is 100 by 250. Similarly, this becomes 60. Then later on, moment of inertia about x-axis, that is ay, is equal to area, how much? 12,000 into 60 y dash value, that is around 60,000. Then similarly this becomes 12,000, not 12,000, 1,20,000. Now semicircle, same, refer these formulas in the table which have been given. Then triangle, circle, then we need to calculate all the summation of areas. Finally we'll get 18,270.36. Later the summation of ay will become 11,65518, and movement of area about y-axis, that is a-axis, 1343172. So at last we need to calculate x bar and y bar. X bar formula is summation of ax divided by summation of a. What we have got? 1343171.13 whole divided by 18,270.35. We'll get the value of x bar, that is 37.52 mm. The unit for all these problems is in millimeters. Similarly, for y bar is summation of ax divided by summation of a, that is 1165517.5 divided by 18270.35. We'll get 63.79 mm. Thank you for watching my video. Please like for the video.